Alrighty, for this next one here, we're looking at the area of a composite figure. Okay, so a few things to keep in mind here. Just do this work today. You have to be able to what's called decompose a figure into shapes that you can work with. So when you decompose areas of things, we're looking for shapes like circles, and the area of a circle is area equals pi r squared. If you have a triangle, and the area of a triangle equals 1/2 of the base times the height. If you're looking at the area of a square, then we're going to be talking about the length times the width. And then if you're looking at perhaps a semicircle, that's 1/2 of pi r squared. And then finally today we'll also be looking at what if you have a trapezoid, like so. And a trapezoids formula is going to be 1/2 of the height times the top plus the bottom of the trapezoid. Okay, so there's a lot of formulas here that you have to have memorized in order to do this lesson here. So you might want to make yourself a little note card of those formulas and have it handy when you do the problems that you have. Today's homework really just consists of 4 problems, but you're going to need to know most of that to figure that out. Okay? So let's take a look here how this works and what decomposing a figure actually means. So for the first one, it says find the area of this thing right there. Well, when you look at this figure here, there's a couple ways of looking at it. We see here that I have in the top a semicircle, right? So there's a semicircle right there that I could figure out. And then I also have this trapezoid figure here. So it's really made up of 2 parts that I can use to put together to solve. I can solve the area of this one and then the area of this one and join it together to find out the total area of the composite figure. Okay, so in the first case here we have a diameter of 14. So I'm going to use that semicircle formula for 1/2 pi r squared. And you can see what we did is let's just look at this by itself. Okay, so the radius is what I need to use, and I don't have that. So radius here's half. It's only going to be 7. So we're going to put a 7 there for our radius and make it half of a circle because it's not the whole circle, and then multiply that out to get about 77. Okay, that's how we did here for this one, breaking it apart. Trapezoid, they use the formula 1/2 of the height, and you can see they gave you the height here of 10, so that's where the 10 comes from. And then B1 plus B2 just means let's look at the base of one plus the top of the other of that trapezoid, add them together, and when you do all that math, you end up with 160. So when you put them back together, the idea is I take my 77 and I take my 160 and I combine them back to make my composite figure, which is about 237 square inches. So just lots of little steps along the way to make that work. Okay, let's take a look at number 1 real quick, because that's just a good example of kind of everything, right? Here with number 1, we have a couple things we could do. We could consider this as we could look at this as a triangle here and a semicircle, or we could look at this as a trapezoid here, which works just the same. We could definitely do trapezoid if we kind of know what everything what's going on. So I'm going to assume we have a trapezoid here where I have a semicircle, and this is going to work as a trapezoid for me, okay? Because I don't know what this length is, so I'm going to assume this is 8 and 8. Okay, so for the semicircle, we're going to do 1/2 pi 3.14 times the radius. Well, I have a diameter, so I'm going to make the radius as half, so 3 squared. So this becomes 0.5 times 3.14, and 3 squared is 9. So when I calculate that out, I have 9 times 0.5 times 3.14 for 14.13 for the semicircle. And then for the trapezoid, we have the formula is 1/2 times the height, which the height of this is 5, times base added together. We would say 8 plus 8, which is 16. So I have 16 times 5 times 0.5, which equals 40. Combine those together, I'm end up with 54.13 millimeters squared is what we're doing right there. That's the idea. Okay, now for number 2, we can see clearly we have a triangle. I have a length here of 9, so I could do 1/2 of the base times the height. It doesn't matter which is which, so keep that in mind. I could call 9 times 6, doesn't matter. I'm going to use the half with the 6 to make that 3. And then 3 times 9 is 27. So I have 27 there in the triangle. The square is length times width, which is 81. So now I'll combine those for a whole 108 feet squared for the area of that composite shape there. So did a little bit of both, trapezoid and semicircle, triangle and square. I'm going to let you do the rest on your own, or not the rest, but I'm actually do the homework on your own. Again, there's only 4 of them here. So as you do your homework, and we'll come back to this in a second, this first one we have a series of what? Look at it carefully. We have a square and we have circles. And when you combine those semicircles together, make a whole circle. Here we have some triangles and a rectangle or square. Here we have a rectangle, and you can see they're cutting out a part. So we're going to want to remove a section. So instead of adding things together, we're going to subtract that part right there. And number 7, just it looks a little bit crazy now, doesn't it? So we have to figure that one out. We'll come back to that one in a little bit. That one's more of a challenge problem for you to see if you got this going on. Okay, see you in a minute. All right, here we go, number 1. First of all, we can do the inside part, which is a square. That's easy enough there. That's going to be 7 times 7 for 49. Now, when it comes to the area of these circles, because it's half a circle here, we can use the area equals pi r squared. Now, I don't have a radius, but I have a diameter, so I need to do half the diameter. Let's do 3.14 times half a diameter, which is 3.5. I'm going to square that. Now I have one circle here, but I have another one here. So I actually can take the whole thing and multiply it all by 2 to save me some time, because I'm going to do it twice. So let's do my square. 3.5 times 3.5, which is actually 12.25, times 3.14 times 2. Now I'll multiply all that together to get 76.93. Nearest tenth, we'll get there in a second. So 76.93 plus the 49 is 125.93. I can chop that off and leave it there at 125.9 centimeters squared. Okay, kind of fun. All right, the next one here. We have a length of 30 and a height of 15. So I can do 30 times 15 to find that area. That one's straightforward. So we have 450 right there. Got it, inches squared. Over here we have 1/2 of a base times the height. So a half of 10 is 5, and 5 times 15 is 75 right there. Over here, I still have this same height of 10. So busy, so many names. Hope you've heard a million names the last few days. I have. And we have 1/2 times the base times the height. So this is going to be half of 10 is 5. So 5 times 5 is 25. So in here is 25. So 25 plus 25 is 100. Plus 450 is 550 inches squared for that one there. And number 5, we have, first of all, we have a rectangle, which is 13 by 9. So 13 times 9 is 117. But now I got to cut out a part. Well, that semicircle is 1/2 pi r squared. Half, as I'm going to say, is 0.5. Pi is 3.14. And half of 7, because that's a diameter, is 3.5 squared. So let's do that. 3.5 times 3.5 is 12.25 times 3.14 times 0.5 is 19.23. Again, I can round that to 19.2. but I'm taking that away. So what I want to do is 117 minus 19.2. Alright, so we have 6, 10, 8 decimal. We're going to put 0 there. 16 minus 9 is 7, 10 minus 1 is 9. So we end up with 97.8 meters squared is what I have in that space once I get rid of that semicircle. Okay, and then finally I have this crazy part right here, which is just crazy. A couple things I could think about chopping it right there, because I know, well, that doesn't quite work. That makes it weird. Not sure what I would do with that one there. This is a weird problem, right? It's a composite figure. How would you want to break it up? I guess that's what you have to figure out what you want to do. Probably they're going to want you to kind of look at the extra shapes and extend this out and then subtract some parts away is what I would assume. Okay. I can assume what some lengths are going to be, that kind of thing. This is just a very odd problem. Am I worried about it? I'm not worried about it, but I'm just going to say if you did it, awesome. Right now, I've been just back-to-back videos in a crowded, noisy Starbucks with flight delays. I'm going to skip it myself and call it a day because I'm exhausted. All right, we'll see you next time. Bye.